Good afternoon. Today I will be presenting my final project and we will be explaining the separating techniques. We have the first one, filtration, which is a process used to separate insoluble solids from liquids in a mixture. For example, removing sand from a saltwater solution. We have crystallization, which is a method of separating a solid from its solution by allowing it to form crystals as the solvent evaporates. For example, we have obtaining salt from saltwater. We have the separating funnel, which is a technique used to separate invisible liquids. Invisible liquids are liquids that do not mix based on their densities. For example, separating oil from water. We have distillation, which is a process involving evaporation and condensation to separate a liquid form or a liquid from its solution or a mixture of liquids with different boiling points. For example, we have separating ethanol from water. We have fractional distillation. It's a specialized form of distillation for separating a mixture of liquids with close boiling points. For example, we have refining crude oil into gasoline, kerosene, and diesel. We have chromatography. It's a method used to separate substance in a mixture based on the movement through a stationary phase under the influence of a solvent. Example, we have separating dyes in the ink. And the last one we have is centrifugation, which is a process that separates particles in a suspension by spinning it at high speeds, forcing densities particles to the bottom. For example, we have separating cream from milk. Now we have our procedure. We are aiming to separate a mixture of water using coloring food or food coloring and kerosene using a plastic bottle that we previously modified using a screw, or you can also use a needle, right? And of course we have to use this bottle as our separating funnel. Materials that we will be using is our plastic bottle, our breather stamp, we have our funnel, our conical flask, we have our beakers, one with the water and one with the kerosene, and we have our spatula because we don't have a steering wheel in this case. And the last thing we're using is the food coloring, right? Any color. Also the screw that we are going to be using to stop the liquid from separating. Okay, so for our procedure, I already have my bottle here, which I previously poured using my screw. You just gotta do a small hole. So you just put it here. Then, in this case, we are gonna mix the water and the kerosene. As I say, I have 100 milliliters of water. I am just going to drop some food coloring so we can make this process a little better. Okay, I think that's enough. Not much. Just going to stir it a little bit. There you go. Our next step is pour our kerosene. Just like this. Now we have this like a mixture. I am just gonna remove my bottle, right? And pour the mixture. Being careful. So you just pour. Just like this. Okay. What I'm going to do now, I'm going to make sure I like this properly. And I am going to put my screw just like this, right? Like this. Okay, so after 2 minutes, we are now going to lose the screw. We already can see the separation, right? But we are going to lose the screw in really careful. Like this. I will have to squeeze a little bit. Bottle. Like this. Squeeze it more and more. This until you finish with all the water, right? Like this. Okay, so just watch me a little bit. So there we go. For our observations, we have that in this case, the addition of coloring water that we use makes more evident the difference between the kerosene and the water. That's why we basically use food coloring. And we almost completely extract all the water into this conical flask, and the rest of the kerosene we made in the separating funnel that we use in this case, right? The kerosene, being less dense, floats on top, while the water settles at the bottom, ensuring an effective separation. Right? So for the conclusion of our experiment, by using food coloring, we could better demonstrate the separation of two similar-looking invisible liquids, as I said, water and kerosene in this case. And this experiment shows how simple plastic bottle would be performed and used as a separating funnel in case we don't have any, right? When it comes to the physical and chemical changes, the physical changes occurs when the forms or appearance of a substance changes, but its chemical composition remains the same. These changes are often reversible. We have some of the characteristics are that no new substance is formed, the changes affect physically properties such as the shape, the state or the size, and the process can be often be reversed, right? For example, in this experiment, we have the separation of the water and the kerosene, and based on their densities without any changes or any chemical composition or any chemical changes, right? Adding food coloring to the water change the water appearance, but does not modify the composition of the water. Other examples, we have melting ice into water or breaking a piece of glass. Okay, when it comes now to the chemical changes, we have those that occur when a substance is transformed into a new one or more new substance with different chemical compositions. Characteristic, we have new substances are formed, we have energy changes such as heat, light, or gas, also production. So we have also that the process is typically irreversible. We cannot make it reversible, right? As in the other one we explained just now. So for the examples, we don't have any in this experiment, but using other examples, we can say that the burning kerosene produces a new substance like the carbon dioxide and water vapor. And also roasting from the iron, which is a formation of iron oxide, when iron reacts with oxygen and water. Right? For instance, the separation of water and kerosene in this experiment is a physical change as the two liquids retain their original properties after separation. No chemical reactions occur, and the process can be reversed by recombining the liquids. Right? So basically with this, we finished with our experiment. Thanks for watching, and Merry Christmas.